It's one thing to watch humanoid robots showing off in polished demo clips, flipping, dancing, lifting weights like sci-fi athletes, but it's something entirely different when one suddenly goes haywire, like it's been taken over by something. That's exactly what happened with a Unitree H1 robot named Dre during a test, and yes, it was all caught on camera. In a video posted by Rec Robotics' 6 Live, Dre is seen hanging mid-air from a crane when it starts violently flailing. Its limbs crash into the equipment, shaking the entire crane structure, and engineers nearby are forced to back off quickly. The scene turns chaotic fast. You can even hear someone yell, "What the f did you guys run?" while another, believed to be Rec CTO Amanda Watson, shouts in shock. So, what exactly went wrong? According to 6, the robot's full-body control system was mistakenly activated, while its feet weren't touching the ground, kind of like slamming the gas pedal on a car that's still on a lift. The robot's system couldn't compensate and things spiraled out of control. But naturally, most people online didn't focus on the software bug. They just saw a humanoid robot freaking out midair, and it felt like something out of the Terminator. And here's the chilling part. Dre isn't some secret lab prototype. It's built on the Unitree H1, a commercially available humanoid robot. It stands nearly 6 feet tall, weighs 104 pounds, and each joint can generate up to 365 pound-feet of torque. That's enough raw strength to do real damage. These machines are built to sprint, lift, balance, even backflip. But when something goes wrong, like a glitch or misstep in code, the consequences can be dangerous. And Dre's incident wasn't isolated. Back in May, another Unitree robot, same model, went rogue during a crane-suspended test in China. It suddenly thrashed around, knocked over a nearby computer, and sent 2 engineers running. Again, the cause? A software error. One engineer was only able to stop it by manually repositioning the base. And even before that, in February, a humanoid robot went off script during a public festival in China. It was behind a barrier, surrounded by a crowd, when it suddenly lunged forward, startling everyone. Security had to intervene, and once again, people were left asking the same question. What happens when a powerful humanoid robot glitches in public? We're starting to see a pattern. These highly advanced robots are moving beyond the lab and into the real world, and with that shift comes unpredictability. Especially under stress, these machines can behave in ways no one expects. So that raises a much bigger concern. How do we define safety for machines that walk, move, and act like us, but are strong enough to cause serious harm if things go wrong? Experts at the Humanoid Hub compared it to the early days of automobiles. A century ago in the US, the fatality rate was 20 deaths per 100 million miles driven. Today, it's under 1.5. Not zero, but dramatically better. And that's the kind of progress we might hope to see with humanoid robots. We're in the early unpredictable phase now, where mistakes, malfunctions, and even misuse are inevitable. But hitting pause on development out of fear? That might be the real danger. These machines could one day assist the elderly, perform risky jobs, or respond in disasters. Overregulating now could choke off innovations that have the power to save lives and transform industries. Still, one truth remains. Humanoid robots will never be 100% safe. There's no such thing as perfect code or flawless hardware. Whether it's bugs, hardware failures, weird environments, or just human error, things will go wrong. So the real challenge isn't perfection, it's deciding how safe is safe enough. That's where data matters. Just like with cars, planes, and industrial systems, we need to collect real-world evidence. And right now, China is racing ahead on that front. On July 18th, they launched a massive new training ground for AI-powered robots in Mianyang, Sichuan. But this isn't just another lab, it's a full-scale testing arena. Think of it as military boot camp, but for humanoid robots. The facility includes advanced research zones, commercialization programs, and most importantly, extreme scenario simulations. The goal? To tackle the biggest challenges in robotics: poor quality training data, limited feedback loops, and the inability to safely test bots in the kind of messy, chaotic conditions they'll actually face. Because the real world isn't clean or predictable. There's noise, dust, motion, unpredictable people, uneven surfaces, things labs just can't simulate. A robot that performs flawlessly in silence might struggle in a crowded subway or a noisy construction site. The training hub is organized around one core innovation center focused on systems integration, algorithm development, and pilot-scale production. It also includes 2 major scenario bases to test robots in sectors like emergency response, manufacturing, urban services, even tourism. And the ambitions are huge. By year's end, at least 7 robotics firms will be working at the facility. By 2027, that number jumps to 30, with plans to launch over 10 new robotic products and integrate 30-plus breakthrough technologies into real industries. It's all backed by a provincial government fund, and the aim is clear: to make China a leader in embodied AI. And the stakes are massive. China's humanoid robotics market is expected to hit over $120 billion by 2030. So while these robot fails may seem chaotic today, they're part of a much bigger picture. This isn't just about fixing bugs, it's about building an entire industry. Because these robots aren't toys anymore. They're being designed for real jobs, whether that's moving boxes in warehouses, assisting in hospitals, responding to emergencies, or even battling other bots in competition arenas. That opens up new opportunities, new risks, and a major need for new safety systems that go beyond code. If humanoids are going to live and work alongside us, on streets, in factories, even in homes, we need to know exactly how to manage them when things don't go as planned. That means better training environments, smarter fail-safes, clearer regulations, and more transparency about what these machines are actually doing. So yeah, watching a robot go wild mid-test is scary, but it's also a sign of the times. These machines aren't science fiction anymore. They're here, they're powerful, and they're evolving fast. Let us know what you think in the comments. Subscribe to this channel. See you in a next video.